Okay, Algebra 1, let's talk about working with sets. Sets are very, very useful in describing the elements or the solutions to inequalities, and we're going to use them when we start talking about compound inequalities in the next couple of days. So let's first figure out what all this mess is. Here's a little table I would like you to take a second to copy down, and we're going to be filling this in over the next couple of days. You will be able to fill in some of this at the end of this video, and the rest we should be able to fill in by the end of class. Excuse me, by the end of our next class. Okay, so we have our notations, right? Let's do an example of writing something in roster notation or builder notation. If n is the set of natural numbers that are less than or equal to 12. Well, in roster notation, that's going to look like this. We're going to list each element of all of the natural numbers that are less than or equal to 12. And we remember that 0 is not a natural number, that's a whole number, so we start with 1. Natural numbers are like counting numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, and 12. And that's every element of the set that meets this criterion. Less than or equal to 12. Natural numbers that are less than or equal to 12, right? Well, what does that look like in set builder notation? In set builder notation, we're going to algebraically represent of the numbers that we're looking for. So again, we have our little brackets. Only this time we're going to describe n. We're going to say all n such that n, hang on, okay, such that n is less than or equal to 12. It's a really nice shorthand when you have a set that has a lot of elements. Instead of listing them all out, we can describe it this way. And unless you're specifically asked to use one notation or the other, you may choose whichever one you think is most convenient. Okay, we have a little vocabulary we have to take care of. A universal set is the largest set that you're using for a given problem or situation. So it's arbitrary. It changes from problem to problem. Subset is a smaller set of the elements taken from the universal set, and a complement of the subset are all the elements that are left in the universal set after you have created the subset. An empty set or null set is a set that has no elements. It's not the same as 0. 0 is an element, right? A set that has no elements is an empty set or a null set, and that is noted, come on, like this. You can write it like that, or you can write it with just like brackets. These are supposed to be brackets with nothing in them. These are two notations for empty or null set. Okay, so let's do an example. So find all possible subsets of the universal set of Arabic numbers. So my universal set is going to be what? I'm going to change my point here. I'm going to have u in roster notation is 0, 1, 2, 3, hang on. Why am I not writing? 3, 4, 5. Right, these are all the Arabic numbers, all Arabic numerals. We can write this in set builder notation, but it's not really practical to do that. But let's go ahead and try. N such that n is any Arabic numeral. And so now let's try to find a subset. So we're going to find all the possible subsets of universal set of Arabic numbers. It's going to be a lot. And I'm only going to use roster notation for this particular example. So first we have an empty set, right? That's one subset. A null set is a subset of every universal set. Then each one of these individual numbers could also be in a subset all by itself. So we can say 1, 2, 3. My brackets are getting worse and worse. 4. And so on, right? All the way to 9. Oh, I forgot 0. Okay, well, we can also do subsets of 2. I'm going to call this subset A. We can do, subsets of 2 numerals. So I could do 0, 1, 0, 2, 0, 3, all the way to 0, 9, right? Now let's call that set B. We can do one, 2, and notice we already have 0, 1, so we don't down here need to rewrite 1, 0. We've already got a set with both of those elements, and the order does not matter. So we don't need to rewrite it in this next line. So now we have 1, 2, 1, 3, 1, 4, and you get the idea, all the way to 1, 9. And we keep doing that. And each line will get shorter and shorter. That's just all the way to 2. Wow, why do I keep doing that? 2, 9. And each line gets shorter and shorter because we don't have to repeat a set that has already been written, right? So for again, here I have in this line 1, 2. When I start listing my 2 first, I don't have to go back and list 2, 1. I already have a set with 2 and 1 in it, and because the order does not matter. So 3, 4, 3, 5, and all the way to 2, 9. I'm sorry, 3, 9. Well, what about sets with 3 numbers in them? Oh yeah, we can keep going. We can say 0, 1, 2. 0, 1, 3. All the way up to 0, 1, 9. And we can keep doing this. We do it for all 3 numbers over and over and over. And then we do it for 4 numbers. Because these are all possible subsets. We have subsets of 1 number, we have a null set, we have a subset of 1 number, we have subsets of 2 numbers, subsets of 3 numbers, and subsets of 4 numbers, subsets of 5 numbers, starting with 0, 1, 2, 3, 4. And it just keeps going. So when you're asked to write subsets of a universal set, this is what you need to do. Now, fortunately, you won't see too many universal sets with that many elements in it. But you could see a universal set with probably 4 or 5, 6 elements in it. Okay, so let's look at, and we'll do some more of these in class. Let's look at another example using the other vocabulary words that we have. A universal set of, let's say, is Arabic numerals again. So once again, my U is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So now I'm going to define the subset. I want you just to find not all of the subsets from this universal set, but just the subset of numerals included in my phone number. Well, you need to know what my phone number is, right? And this isn't my real phone number, so please don't call it. Whoops. So what is the subset of, whoops. What is the subset we are looking for? And let's call it subset A. Well, we have 2's. Let's cross those out. I'm just going to go in numerical order. 2. I don't see 3, but I do see 4. And I don't have to list each 4 I see or each 2 I see. I just have to list each element once. I see a 5, and I see a 6 and a 7. So that's subset A in roster notation. 2, 4, 5, 6, 7. 1, 2, 3, 4, 5 elements. So the complement of this subset is going to be noted A prime, and in roster notation, that's going to be any number from the universal set up here that we didn't use in the first subset. So let's see, we didn't use 0, we didn't use 1, we used 2, we didn't use 3, we used 4, 5, 6, and 7, we didn't use 8, we didn't use 9. This is called the complement of this set. A prime is the complement to A. So let's do one more example, and again we'll use roster notation. Let's say months of the year. So in roster notation, oh, my brackets are just getting horrible. We have January, I'm going to abbreviate, February, March, April, May, June, July. Right? That's in roster notation. In set builder notation, you could write M such that M equals any month of the year. Right? I'm sorry, all months of the year. Okay, so now let's say we want a subset that describes months with exactly 31 days. Well, we need to figure out which ones those are, don't we? In roster notation, I'm going to call this universal set. I'm going to call this set A. In roster notation, we would say January, not February, March, not April, May, not June, right? July, I believe August, October, and December. So what then is the complement to our subset? Well, it's all the months that weren't used in the set, right? The complement to A, or A prime, is going to be February, April, June, September, and November. Wait, what am I missing? Nope, they're there. Just for the heck of it, how would we write this in, let's say, the subset in set builder notation? Oops. Right? Okay, so that's it for this video. We will do more examples in class, but do note the table and go back now and see if you can